So the last three examples are pretty much just a review of how we can solve a system of linear equations. So now, let me get to the main dish of this lecture, which is the linear combination. So, if I have a bunch of vectors here, let me call it v1 to vn, and here, I'm gonna use a bold-faced letters to mean vectors, by the way. So I have a bunch of vectors v1 to vn here. I'm gonna call this guy a vector u a linear combination of v1 to vn if I can write this vector u as a sum of something times v1 plus something times v2 and so on plus something times vn, where this something a1 to an, they are scalar, they are just numbers. So notice how my bold-faced u and my bold-faced v, all the yellow vectors here are vectors. But the a here, these guys are scalar, by the way. So here I have scalar times matrix scalar. So let's take a look at the examples down here then. Let's say my vector v1 and v2 is just 1, 2, 9 and 5, 1, 3. If I want to find the linear combination to v1 plus 3 v2, well, this should be pretty simple. It's just going to be 2 times v1, which is 1, 2, 9, plus 3 times v2, which is 5, 1, 3. And I can compute this right away. So the first entry is going to be 2 plus 15, which is 17. The second entry is going to be 4 plus 3, which is 7. And the last entry is going to be, let's see, 18 plus 9, so that's 27. Okay, so now here, my matrix, this is going to be my U matrix then. So this guy, this blue guy is basically a linear combination of the two yellow guy, which is just v1 and v2, because I can find a scalar such that 2 times v1, 2 times this yellow guy, plus 3 times this yellow guy is the blue guy here. So now let me try the next one. If I want to find the linear combination negative v1 plus 4v2, well, this is the same thing. So it's just going to be negative of 1, 2, 9 plus 4 times v2, which is 5, 1, 3. And let's see what this is going to give me. I have negative 1 plus 20, so that's 19. I have negative 2 plus 4, so that's a 2. I have negative 9 plus 12, and negative 9 plus 12, that is a 3, so I have a 3 here. So once again, this blue guy is a linear combination of my two yellow guys here. Okay, so this is not that bad, but let's take a look at the next part. I'd like to find if this vector, so now this is going to be my blue guy. I'd like to see if this blue guy is a linear combination of v1 and v2 in particular. So if I go back to definition, the blue guy is going to be a linear combination of the yellow guy if I can find a number a1 and a2 such that this blue guy is something a1 times this yellow guy and a2 times this yellow guy. So this guy is going to be a linear combination of v1 and v2 if I can find a1 and a2, if I can find a1 and a2 such that 11, 4, 15 equals let me just use a and b here, equals a times let me see, so my v1 is 1, 2, 9 plus b times v2, which is just 5, 1, 3. So if I can solve this equation, if I can find a and b that satisfy this equation, so I can make something times the yellow guy equal the blue guy, then I'm gonna get that this 11, 4, 15 is a linear combination of v1 and v2. So now it's just a matter of solving this equation. Notice how I can write this equation into the typical linear equation form. So let me actually move the 11, 4, 15 here to the right hand side, just so we are more familiar with this form. Okay, so my variable is on the left hand side and my constant is on the right hand side. So I can actually write this as an as a system of equations, and that is going to just be a times 1 plus b times 5, which is a plus 5b, has to equal to 11. And then 2a plus b, 2a plus b equals to 4. And then 9a plus 3b, 9a. So my 9 and my a are a little hard to tell apart, by the way. So this is 9a. 9a plus 3b is going to be, let me see, 15. Okay. So I can solve this system of equations and see if there is a solution. Or I can also turn this into a matrix equation. So the matrix equation for this is going to be just, let me see. So I'm going to have, let me pull out just the number here. I'm going to have 1, 2, 9 and then 5, 1, 3 times the vector AB. This has to equals to, let me see, 11, 4, 15. So here is my matrix equation. Notice how this is actually just the same as the if I pull out the numbers from this system of equation, this is what I'm gonna get as well. So let me actually solve this equation using the matrix method. Then I can turn this into augmented matrix. So this guy in augmented matrix form would just be, let me see, I'm gonna augment the right hand side to my matrix here. So I'm gonna have 1, 2, 9, 5, 1, 3, and then 11, 4, 15. So now this is my augmented matrix form, and this is going to be the equation that I'm trying to solve. So I'm gonna try to use the Gaussian elimination to turn this into a reduced row echelon form. So let me try that now. First thing first, it seems like I can divide the third row by 3. So let me do that first then. So the first two rows stay the same. 1, 5, 11, 2, 1, 4, and then 3, 1, 5. It seems like I can use this guy as my leading one. So then I have to turn this 2 guy into 0. So this is going to be my first blue bar. I need to turn this 2 guy into 0, so let me do that now. I'm gonna subtract 2 times row 1 from row 2. So row 2 minus 2 times row 1 is going to be, let's see, 0 here and then negative 9 here. 4 minus 22 is negative 18. And now I'm gonna subtract 3 times row 1 from row 3. So my row 3 minus 3 row 1 is going to be 0 here. 1 minus 15 is going to be negative 14. And then 5 minus 33 is going to be negative 28. Okay. Now then, I can divide, so let me see, my first row stays the same. I can divide the second row by negative 9. So negative 1 over 9 times row 2. If I divide row 2 by negative 9, I'm just going to get 0, 1, 2. And if I divide negative 14, if I divide the third row by negative 14, I'm going to get also 0, 1, 2. Now then, it seems like I have my second leading one here. So this is my first blue bar. This is my second blue bar. This is my leading one. This is my leading one. This guy and this guy is already 0, so I'm happy. Now I need to turn this guy and this guy into 0. So let me try that next. I'm gonna subtract 5 times row 2 from row 1. So let me see, 1. This one stays the same. 5 minus 5 is 0. 11 minus 10 is 1. Then second row stays the same. 0, 1, 2. If I subtract row 2 from row 3, everything is going to get cancelled out. So I'm just going to get all 0. And this is fine as well. So if I were to write out, this is row 1 minus 5 row 2. And then this is row 3 minus row 2. So here my matrix is already in row echelon form. So I can see that if I were to look at my original equation, that would mean my 1 times A is going to equal to 1. So my A is 1. and then my 1 times b is equal to 2, so my b is equal to 2, and this is indeed the solution to my equation here. You can try that. If my a is 1 and my b is 2, so let me see. So I'm gonna get 129 plus 2 times 5, 1, 3, and I will get the vector 11, 4, 15 here. So that means this blue guy 11, 4, 15 is indeed a linear combination of my yellow guy, because I can find the value for a and b here is just 1 and 2. So this guy is a linear combination of v1 and v2. So now let me try part D. I like to find if my blue guy, same thing here, is a linear combination of these two guys. So let me actually just go ahead and write out the equation. I like to see if I can find a and b such that a times v1 plus b times v2 equals to my blue vector here, 630. I can turn this into the matrix form. That will just be 1, 2, 9, and then 5, 1, 3, and my right hand side is going to be 630. Okay. Notice how my pink matrix form here is quite similar to the blue matrix form that we have earlier. And that is because the blue vector, the yellow vector here, 1, 2, 9 and 5, 1, 3 is just the same thing. Only my blue vector has changed. So that is why my right hand side here has changed. So now let me actually just write out the reduced row echelon form for this guy. If I do the same Gaussian elimination, the reduced row echelon form for this guy is going to be 1, 0, 0, 0, 1, 0, and then 0, 0, 1. Okay, this is already in my reduced row echelon form, but this actually spells trouble. If I were to write out the equation, the original equation, if I were to turn this into the equation form, what I'm going to see is 1 times a plus 0 times b equal to 0. So I'm going to have that a equals to 0, and then 0 times a plus 1 times b equal to 0, so my b equals to 0. The last equation now becomes 0 times a plus 0 times b, which is 0, and that has to equal to 1. So now this spells trouble. So what that means is there is no solution to this equation. So I cannot find a solution. I cannot find a and b that satisfy this pink equation. So what that means is I cannot write this blue guy as something times yellow guy, v1, plus something times yellow guy, v2. So that means 630 is not a linear combination of v1 and v2.